Okay, so today we're going to learn about, today we're going to do hack assembly programming. We're going to multiply 3 and 4. And something as easy as this is very tedious in a lower level programming language. And how do we do that? Well, we start off by loading a value into one of the registers. We have got A, D, and M. We will go into these details later. But for now, let's store the number 3. We want the number 3. We are storing it in our A register. That's how we store it. We give at the rate and 3, that's the syntax. So we stored 3 is stored in A. What do we do next? We have to store it in one of the memory locations. So we have to store it in one of a part of in a part of our memory location. So how do I do that? So let's take another register and store the value, store 3 in another register. We can use the D register, and M register is used for memory, the RAM that we are going to store it in later. So if I write it down, so D is equal to A, meaning assign A to D. So now D is equals to 3. We assigned A to D. Then we can choose a memory location where we'll store the value of 3. We'll store it in a memory. For now, it's loaded in a register and we need to store it in a memory so that it stays. So let's choose memory location 10 for now. So how do I do that? I can write at the rate 10. This is for the memory location. Memory location. And then how do I store my number in the memory location? I can just write m equals d, meaning m equals d, as the previous line suggests, we have taken a number 10 that will be a part of the memory. So it will work like this. So I have stored the d value in RAM 10 equals d equals 3. Okay. So I guess I've done the first part of my program to multiply 3 and 4. So I can write it down. We stored 3 in one of the memory locations. Now let's try storing 4 in the similar fashion. We can load 4 at first, store 4 in one of the memory locations. So we can do at the rate 4. We can store it in our D register, D equals A. So this is 4 stored in A at first. Then we store the A value in our D register. So 4 is stored in D now. So D is equal 4. Then we'll store the value in a memory location. We have it in our register, we'll keep it in our memory location. So how do I do that? I used at the rate 10 already. Let's use at the rate 11, another memory location. So let's use at the rate 11. And then I can just do m equals d, which means RAM 11 equals d, and d is equal to 4. Okay, so I am done with storing both the numbers. I stored 3 and I stored 4. Now I need to multiply. Now, how do I multiply? I have to use a loop because there is no such thing as direct multiplication in a lower level programming language. So, what do I do? I need to use a counter. I need to use a counter, and I need to store my results somewhere. I need to store my results somewhere and keep on adding there. For example, I can take a number, I can keep it as 0, and I can keep on adding 3 to my 0. So I can keep on adding 3. So 0 plus 3 is 3, and then I will re-add 3 with the first solution. So I can now add 3 with 3, that gives you 6. Then I can add 6 with 3, that gives you 9. Then I can add 9 with 3, that gives you 12. We need to use the previous answers. So how do I do that? So it all started with a 0. So I'll store the 0 somewhere. So let's store 0 in RAM 0. That's the most easiest way to remember. So let's take the number 0 and let's store it in 0. So what I did here is I took RAM 0 equals 0. 0. Okay. So I have set a result variable. I've set a result variable. Set a result variable, and it's equal to 0 because I'm going to need it. I'm going to add 3 to it every time in every iteration. So we need to use a loop now. So before using a loop, and it's a counter control loop. So how many times am I looping here? 1, 2, 3, 4. So 4 times. So every time I do a loop, I will subtract 1 from my counter. So what can I take as counter? Yes, the number that I'm multiplying it with. So I can take the 4 as my counter. How do I do that? Look, it's already in a memory location. It's already in RAM 11. The value 4 is already stored in a memory location. So I just need to call that and place it somewhere else. That's it. So how do I do that? I can call RAM 11. So how do I do that? Let's set a counter. So at the rate 11, then I'll do d equals to m, meaning store the value of RAM 11, store the value of RAM 11, sorry, RAM 11 in D. And then what I can do, I can take the value out and put it in another memory location because I want it to be separate. I don't want it to overlap with my previous value. So what I can do, let's take RAM 12 now because we didn't use it in D, sorry. So let's take the value RAM 12 and let's place it in our memory location. So m equals D. So what I did here is I took at the rate 12 and then m, meaning I took RAM 12. I took RAM 12 and I placed it, I assigned D to it, and our D value was RAM 11. So RAM 11. And what was RAM 11? RAM 11 was 4. That's it. We set a counter. Now I need to decrease the counter every time I do an addition. I need to decrease the counter. How do I do that? I use a loop. So I will use a loop. And in the loop, I will decrement the counter till it reaches 0. So where is the counter stored? The counter stored at 12. The counter stored at RAM 12. How do I do that? So if I choose at the rate 12 and if I write D equals M, so I stored the value of RAM 12 in D again, in D register again. Store RAM 12 value in D register again. What do I do then? I will uh, end I will end the loop. When do I end the loop? Only when the value of D, which is RAM 12, which is 4, only when 4 turns into 0 every time I'm subtracting it. So when the 4 turns into 0, I'll end the loop. So I will end the loop only when so this is the next step. Only when I will end the loop, you read it like this: I will end the loop only when D is exactly equal to 0. So we write it like this: JEQ. JEQ means when we jump if it's equal. We jump to end if it's equal to 0. Jump to end loop if it's equal to 0. Now what do I do? I need to start adding I need to start adding 3 4 times. Now how do I do that? Where was D stored? Oh, sorry, where was 3 stored? 3 was stored in RAM 10. So I need to access RAM 10 now. So at the rate 10 and D equals M. So I have accessed RAM 10, which is 3, and I placed it in my D register. Access RAM 10, store it in D register. So now D is equal 3. What do I do next? I have to keep on adding 3. I have to keep on adding 3 as it is in this step right here. I have to keep on adding 3 unless and until I reach 12. So how do I do that? I need to add it with the 0 at first, with the result variable. It will give the final result. The final result will come here. So I'll keep on adding 3, 3, 3, 3 to it, to the result, and I'll finally get 12. So the result variable is stored at 0. So let's access 0 at the rate 0, and then d equals m. Oh, sorry, we don't need d equals m anymore. We can just add our value. We can just add 3 to 0 continuously. So we can do m equals d plus m. So what it does is, as we have 0 earlier, it means RAM 0, the new value of RAM 0 for every time it loops is going to be d plus m. So d is the previous d, which means this one. This is my d now, d equals 3. So it will be equal to d plus m. M is RAM 0. So the value of RAM 0 changes every time. It's the same as doing a while loop. It's the exact same thing. And then what do? Uh, we need to decrement the counter, right? We have to decrement the counter. So we didn't decrement here actually. We just checked the condition. Now we'll decrement the counter. Decrement the counter. This is check condition. Sorry, this was my bad. It checks condition for the counter. Now we'll decrement the counter. Let's access the counter. Counter was stored in, I think it was stored in RAM 10. Yeah, yeah, it was stored in RAM 10. The counter. So at the rate 10. So d equals m. Mm, wait. Sorry. It was stored in number 12, I think. Counter. Did I set a counter? Yeah. It's stored in 12. It's stored in 12. So it's better if I write it down. Counter stored in RAM 12. And we can write it down here as well. Result stored in RAM 0. Stored in RAM 0. Now we'll decrement the counter. Let's access the counter. So at the rate 12, and then I'll decrement the counter. So m equals m minus 1. This part looks like just our typical programming that we would do for a loop in Python or in C. So m equals m minus 1 does this. So it's going to be RAM 12 equals to RAM 12 minus 1. So there will be a new value assigned to RAM 12 every time we run the loop. So at first it's going to be 4, then it's going to be 4 3, sorry, 3 2 1 and 0, because 4 minus 1, it starts from 4 minus 1 3, then 3 minus 1 2, 2 minus 1 1, 1 minus 1 0, and as soon as it reaches 0, we will end the loop. Where is the end condition? Yeah, we'll end the loop. And we'll keep on doing this. After we have done this, we will once again continue the loop. It should be in all caps. Continue the loop, and then after we have done, we are done with the loop. Let's jump back to our program, and then we will use our end loop, which will run the program, which will go to an infinite loop actually to end the program. So we use at the rate end, and then we use 0. This terminates the program. And that's it. This is how we multiply two numbers. And I think you can run it in Nand2Tetris simulator. Nand2Tetris simulator.